Okay, so this is the 8.4 recommended practice video. We're going to go over those problems on symbolizing with identity. So the recommended problems were these ones, right? Page 325, 1A, C, E, and G, and 4C, E, G, and I from page 327. We're going to work through those one at a time. So the first problem was every Wilcox except Daniel is a sailor. I have the symbolization key over here to the side. So the paraphrase that we're going to do is for every x, if x is a Wilcox and x is not Daniel, then x is a sailor. So that's our start of the paraphrase. Here we've said x is not Daniel, which is not a truth functional way of paraphrasing that, right? So we need to change it to for every x, if x is a Wilcox, and it is not the case that x is identical to Daniel, then x is a sailor, which we get this as the symbolization, right? And this is what the textbook has as the correct symbolization for it. But one thing that we look at when we think about except is that except also implies that Daniel is not a sailor, right? So we may want to add in, and it is not the case that Daniel is a sailor. So the complete symbolization for this in this course is this, right? We have for all x, if x is a Wilcox and x is not identical to Daniel, then x is a sailor, and Daniel is not a sailor. Now we have every Wilcox except Daniel is a sailor or the offspring of a sailor. So we've got the same parts that we started with before, right? We're going to start with for every x, if x is a Wilcox and it's not the case that x is identical to Daniel, then x is a sailor. And in the consequent, we need to figure out how to add, or x is the offspring of a sailor. So we don't have a predicate for offspring, right? We have the predicate for son and the predicate for daughter, so we're going to need to use both. And importantly, these are two-place predicates. So we also need to add in the other variable, right? A quantifier for the other variable so that we can say that person is a sailor. So here we're going to add in an existential quantifier, right? There is some y such that y is a sailor and x is the son of y, or x is the daughter of y. So that's how we're going to say x is the offspring of a sailor, right? There is some y such that y is a sailor and x is either the son or daughter of them. So let's get rid of those italics and start adding in our parentheses, right? I've put brackets around everything that involves an x, right? We have x's all the way to the end, so we need brackets to put everything in the scope of this universal quantifier. Then I added in parentheses around the antecedent, right? We have x as we have our if then, so I have parentheses around x is a Wilcox and it's not the case that x is identical to Daniel, and parentheses around the whole consequent. But our consequent is long and a complex sentence itself, right? We have an or, we have an existential quantifier, we have an and we have another or. So we're not done with parentheses yet. Here I'm adding parentheses around the around everything that's in the scope of the existential quantifier, right? We've got three y's, y is a sailor, x is the son of y, or x is the daughter of y. So we need parentheses to put everything in the scope, but we still have an and an or, both together here without parentheses. So one more set, right? Y is a sailor and x is the son of y, or x is the daughter of y. So we end up with three parentheses and a bracket stacked here at the end. It's important to get that in and make sure you have it right, whether you do it while symbolizing or in your paraphrase, so that you do have a grammatically correct sentence. And that overall symbolization looks like this, right? For all x, if x is a Wilcox and it's not the case that x is identical to Daniel, then x is a sailor, or there's some y that's a sailor and x is either the son or daughter of them. So this is our everyone, this is our, or they are the offspring of a sailor. Now, based on and this is what the textbook has as the correct answer in the solutions. Though I do want you to think about it. We're not going to take all the time to do it, but we do have, and it is not the case that Daniel is a sailor or the offspring of a sailor. Again, if you are interested in doing more work, which I think at this point in the semester, most of us are not, you could try to symbolize, and it's not the case that Daniel is a sailor or the offspring of a sailor. It has to be done a bit differently than the original one. But I'm not going to give you any accept problems that involve this level of complexity on any exam. And the textbook does differ from the way that we teach this course, where it doesn't include that clause. So I'm going to leave that one there. Next, we have Daniel is the only child of Jacob. So the solution in the textbook here is actually wrong. The solution in the textbook here is for the sentence, Daniel is the only son of Jacob. So as far as this one goes, trust me, not the solutions manual for the textbook. So when we break this apart as a preliminary paraphrase, we get Daniel is the child of Jacob, and any child of Jacob is identical to Daniel, right? That's the way that we've done all of these only claims. But again, we don't have a predicate for is the child of or is the offspring of. We have one for son and one for daughter. So the best that we can do is use a disjunction of is the son of or is the daughter of. So our paraphrase looks like this, right? Daniel is the son of Jacob, or Daniel is the daughter of Jacob. And for any x, if x is the son of Jacob or x is the daughter of Jacob, then x is identical to Daniel. We have to have that disjunction between son and daughter to capture the only child aspect. So now we're going to add some parentheses. This and here is our main connective, right? You can see it in our first paraphrase. Daniel is the child of Jacob. We have this and any child of Jacob is identical to Daniel. So I put parentheses around each of those conjuncts, right? The quantifier we leave on the outside of the conjunct itself because everything in the rest of this conjunct is in the scope of that quantifier. Then I added some more parentheses, right? We added around the antecedent, and we added around the antecedent here since that antecedent is itself a compound sentence with that or. And this is the sentence that we get overall, right? To say Daniel is the child of Jacob, we say Daniel is either Jacob's son or Jacob's daughter. And to say for any other child of Jacob, they're identical to Daniel, we say for all x, if x is the son of Jacob or x is the daughter of Jacob, then x is identical to Daniel. Okay, next we have Rebecca's only son is Jacob's only son. So what we need to say here is that there is one person who is both the son of Jacob and the son of Rebecca. And if anyone's the son of either of them, then they're identical to this first x, right? So we have there is an x such that x is the son of Rebecca and x is the son of Jacob. Right? We have to say that this one person is the son of both. And for any y, if y is the son of Rebecca or y is the son of Jacob, then x is identical to y. And we use that disjunction instead of a conjunction to say he's not the only child of the two of them together, he's each of their only child. So everything goes within the scope of that first existential quantifier, right? We have an x here all the way at the end. So we need to put brackets to make sure everything's in that scope. This and is our main connective inside the scope of the quantifier. So I have parentheses around one conjunct, which is the conjunction x is the son of Rebecca and x is the son of Jacob. And around the other side, that's all within the scope of this universal quantifier, right? If y is the son of Rebecca or y is the son of Jacob, then x is identical to y. And the last set of parentheses we need is around that antecedent, right? The antecedent is a disjunction itself, so we need the parentheses there as well. And then using our symbolization key, we get there is an x such that SXR, right? This x is the son of Rebecca and x is the son of Jacob. And for any y, if y is the son of Rebecca or y is the son of Jacob, then x is identical to y. So this says there is one person who is the child of both, who is the son of both of those people. And if anyone's the child of either of the son of either of them, then it's this same x. So that's how we get Rebecca and Jacob each have only one son, and that son of each of them is the same person. So next we have 4C. Jeremy is Corey's oldest son. So to say that someone is the oldest son, we want to say that Jeremy is a son of Corey, and Jeremy is older than any other sons of Corey. Now the word other here is important, right? Because if we say Jeremy is a son of Corey and Jeremy is older than any sons of Corey, then we get that Jeremy has to be older than himself. So we get a contradiction there. So to say Jeremy is older than any other son of Corey, we have to say for any x, if x is a son of Corey and it's not the case that x is identical to Jeremy, then Jeremy is older than x. And we have this, it's not the case that x is identical to Jeremy. To specify, we are talking about other sons, again, because if we excluded this, if we just said, if x is a son of Corey, then Jeremy is older than x, we'd have to be saying Jeremy is older than himself. So now we're working in some parentheses, right? Our main connective is this and we need to put everything after the universal quantifier in brackets. And then we have a material conditional, so we put the antecedent there in parentheses because it's a compound sentence, right? It's a conjunction between x is a son of Corey and it's not the case that x is identical to Jeremy. So we get this completed symbolization. Jeremy is the son of Corey, and for all x, if that x is a son of Corey and not the same person as Jeremy, then Jeremy is older than x. So this is how we get Jeremy is the oldest son, right? Jeremy is the son of Corey, and for any other son of Corey, Jeremy is older than them. Next, we have Doreen's eldest daughter is a physician. So there are three things that we need to say with this sentence, right? We need to say Doreen has a daughter, that same person is a physician, and that daughter is older than any other daughter of Doreen. So the last part is exactly the same as the previous one we just did, right? Where we said Jeremy was the oldest son of Corey. But now, because we don't have an individual constant, we need to use an existential quantifier, right? So instead of saying Jeremy is the son of Corey, we need to say there exists an x such that x is the daughter of Doreen and x is a physician. And then we have this clause, just like we did on the last one, for any y, if y is a daughter of Doreen and it's not the case that y is identical to x, then x is older than y. So again, that's similar to the last problem, but we don't have an individual constant here, so we need to use an existential quantifier and that x variable. So now we're working with some parentheses, right? I've put them all in at once. We have the brackets to put everything in the scope of the main existential quantifier. Then we have an and here, so I've sectioned off this first conjunction as one of the conjuncts. X is a daughter of Doreen and x is a physician. Parentheses around everything that goes in the scope of that y, right, all the way around here. And then parentheses around that antecedent for this conditional, since our antecedent is a conjunction, y is a daughter of Doreen, and it's not the case that y is identical to x. So we get this as that completed symbolization, right? There is some x that is a physician and is the daughter of Doreen, and for any other daughters of Doreen, x is older than them, right? So this is Doreen has a daughter that's a physician, and this is that person is older than any other daughters of Doreen. So this one is a bit easier, right? We've got Corey as Doreen's eldest daughter. So this is very similar to the 1-2 problems back. We've got an individual constant, which is much easier because we don't have to involve an existential quantifier. So Corey is a daughter of Doreen, and for any y, if y is a daughter of Doreen and it's not the case that y is identical to Corey, then Corey is older than y. So there are parentheses, they're in the exact same place as the last one, and this is the symbolization. It looks very similar to the previous problems. We've got Corey is Doreen's daughter, and for any y, If Y is a daughter of Doreen and not the same person as Corey, then Corey is older than them. So now we have Corey is married to Hal's oldest son. So we're going to have to use an existential quantifier here, right? We don't have an individual, we don't have a name for the person that is Hal's tallest son. So we need to say there is an X such that Corey is married to them and they're a son of Hal. And for any son of Hal that's not that same person, X is taller than them, right? That the son that's married to Corey is taller than any other sons. So again, we need to add our brackets and parentheses, putting putting everything in the scope of that existential quantifier, and then our parentheses around those conjunctions to make sure everything goes right. And then we get this, right? There is some X such that Corey is married to them and they are a son of Hal. And for any Y, if Y is the son of Hal and Y isn't identical to X, right? So for any son of Hal that's not this same person, X is taller than Y. So it's very similar to the older than oldest cases we just talked about. So that's it for this review video. This is the last complication, as I mentioned before. This is as far as we're going with complicating symbolization. Next, we're going to start talking about assessments and evaluations of predicate logic, right? Evaluating the truth. We're going to start with evaluating the truth value of sentences in predicate logic.